Today we're going to go ahead and classify triangles. We can go ahead and classify triangles by their sides. And then so for instance, if one has all three sides that are equal, it's called an equilateral triangle. And we can also classify them by their angles. And then so let's look at angles first. If we look at this first triangle here, if we classify it by its angles, we're looking at each of these angles. And we're looking at each of those angles, and we're saying that each of those angles is less than 90 degrees. Since each of those angles is less than 90 degrees, they're called acute angles. And lastly, since this triangle does have three angles that are all acute angles, then this is called an acute triangle. It's an acute triangle. All of those angles are less than 90 degrees. Here's a more precise definition. An acute triangle, a triangle in which each of the three angles is acute. So this here is another example of an acute triangle. Each of those angles is acute, or less than 90 degrees. So we're naming that triangle by its angles, acute triangle. A right triangle is defined as a triangle that has one right angle. So my example here is a right triangle. Point at the right angle, please. Ideally, you pointed at this angle right here, because a right angle does have 90 degrees. Oftentimes we will see that symbol for a right triangle. We don't have to see that symbol, but oftentimes we will see that symbol. This also is another example then of a right triangle, because there is a right angle within that right triangle. This final triangle has what we call an obtuse angle in it. That obtuse angle is that angle that is greater than 90 degrees, but less than 180 degrees. And then so, this is the angle we're talking about. That's the obtuse one. The other two angles are acute angles. That's why we call this an obtuse triangle. And there's that definition there. An obtuse triangle, a triangle that has one obtuse angle. Alright, we have three different triangles here. Three different triangles. You match them up. You match them up. Help me match them up. Help me put them back as to where it is that they belong. Go ahead and point at the acute triangle. Point at the acute triangle. Where do you want me to move it? Right here. This is the acute triangle because all three of those are acute angles. Which of those is a right triangle? Which of those is a right triangle? Tell me where to move it. Did you say it right here? On it? Oh, I'll just put it next to it. It'll be easier to see. Finally, this other one is the obtuse triangle. Go ahead and point at the obtuse angle then. Hopefully you're pointing at that angle right there. For the right triangle, again, we might want to go ahead and write that right in there. And so, it's by its angles. Acute angles less than 90 degrees, right angles is 90 degrees, and obtuse angle greater than 90 degrees, if we're thinking about those types of angles. So, one of the ways you can definitely name triangles is by those angles that are inside of them. That other way that I had discussed earlier and just mentioned earlier in our intro was by its sides. So I have these same triangles, and now we're going to go ahead and work with them by their sides, and by the lengths of their sides. I'm going to go ahead and label each of these lengths of these sides for you. This one looks like it's 5, 5, and then this one is also 5. If we're classifying this by their sides, we call it, when all their sides are equal, we call that an equilateral triangle. So not only is that triangle an acute triangle, as from before, but if we were to classify it by its sides, we can also call it an equilateral triangle. In fact, we could call it an acute equilateral triangle or even an equilateral acute triangle to be more specific. Now for this triangle right here, it looks like the length of this side here is probably somewhere around 3. If this was 3 here, those two look like they are equal. However, this other side here looks like it is bigger. Looks like it is bigger. So I'll say that it's 6. I know for a fact that it's not 6 based on something called the Pythagorean theorem, but I'm not going to go into that right now. What I am going to indicate here is both those sides are equal by putting a little tick mark there. And by putting a little tick mark there, that's the geometrical way to show that both of those sides are equal. And so in that case there, since both those sides are equal in that case there, that's what's called an isosceles triangle, where two of those sides are equal. Where two of those sides are equal. Finally, for our final triangle here, none of these sides are equal. And then so what I'll do is I'll put a 1 there, 2 there, and I'll put 3 tick marks there on that one there, indicating that none of those sides are equal. None of those sides being equal, what we call that is we call that a scalene triangle. Scalene triangle. And then so again, for this first triangle here, how many sides did I say were equal? Right, 3. So 3 sides being equal, and you kind of think about that. Hey, equilateral. Isosceles, I kind of think of an ice cream cone, and I think of an ice cream cone because typically I'll see an isosceles triangle that looks like this here, where 2 of those sides are equal. And then finally, for a scalene triangle, I'd write the number 0 here, because none of them are equal. Go ahead and write down all 3 of these for yourself. Equilateral, isosceles, scalene. And I also want you to write down the number of sides that are going to be equal for those. Go ahead and pause the video here and write those down. I just want this written down, please. Alright, let's see if you learned it by writing it down or by looking at it from before or maybe hearing me talk. What type of triangle is this? What type of triangle is this based upon its sides? Based upon its sides, it is a isosceles triangle. 2 of those sides are equal. In fact, it is also called an acute triangle because of its angles. So again, each triangle is going to have its names not only by its sides, but also by its angles. And typically, we don't even separate them. We can write them both together. Here's another triangle. Here's another triangle where each of those sides looks like it's 8 meters. So what do we call that? By its angles, it's still an acute triangle. By its sides, what do we call that? We call it a equilateral triangle. Equilateral. Lateral. Equilateral. And it's a triangle still. So again, it has 2 names. Not only is it an equilateral triangle, but it is also an acute triangle. In fact, all equilateral triangles, they must be acute triangles by rule. Finally, if I have this triangle here, it looks like this angle is actually just a little bit bigger than 90 degrees. So by angle, this here would be an obtuse triangle. It's an obtuse triangle, and it's also a scalene triangle. So I'll write obtuse, scalene, and I'll write triangle. If I was asked to name this triangle, I would not only name it by its angles, but also by its sides. It had 1 obtuse angle. The other ones were acute, by the way. And it had no sides that were equal.